In this video, I'm going to create a schematic for the popular Cloudlifter CL-1 microphone activator using some open source software called KiCAD, spelled KiCAD. If you haven't seen my previous video where I do an in-depth teardown of the Cloudlifter CL-1, I highly recommend checking it out. Links to all the videos in this series will be listed in the description below. If you aren't into the whole CAD design aspect of this project, feel free to skip to the fourth video where we actually assemble a mic activator using the board that was designed in this video series. Before we get started, I need to grab the published schematic symbol and footprint for the LSK389 JFET that's used by the CL1. This is the only part that we will need, which KiCAD doesn't have by default. I'm grabbing this from a website called snapeda.com. Despite this only showing the through-hole footprint, the download for this part actually includes both surface mount and through-hole footprints. This is important because we will be using the surface mount variant. I've already created a new project in KiCAD, and I need to import the downloaded schematic symbol and footprints. They are added independently through the Preferences menu under Manage Symbol Libraries and Manage Footprint Libraries. The symbol gets referenced by the file, and the footprint is referenced by the folder that it's contained in. Let's build out the schematic. We will start with the Add a Symbol button or by pressing Hotkey A. The inputs and outputs for this board are going to be male header pins, so let's add two headers that each consist of 3 pins that will connect to our XLR connectors. Searching for CONN lets us locate a single row 3-pin connector. Let's add our JFETs by searching for LSK. The actual part that we will be using is the LSK389C, but the part that we imported is LSK389B. The difference here doesn't matter because they have the same schematic symbol and footprint according to the datasheet. Something that's interesting about this part is that the schematic symbol has 2 parts to it, Unit A and B. This represents the 2 JFETs that are inside of this chip. Kinda cool, I've never seen a multi-part symbol like this. Since we are using 2 LSK389 chips, this will result in 4 JFETs being present in our schematic. I find the keyboard shortcuts in KiCAD to be super intuitive. Selecting something and pressing M lets you move it, pressing R will rotate it, Command D will duplicate the selected part, pressing E lets you edit attributes related to a symbol, and pressing W puts you in wire drawing mode. I'm going to start connecting the outputs to the JFET on the right. I'll slowly add resistors and capacitors as I need them. Resistors can be found by searching the schematic symbols for R. Similarly, capacitors can be found by searching for C. I'm going to use multiple ground symbols rather than creating a messy nest of wires going to a single ground symbol. I'm just hooking everything up based on what we learned from my previous teardown video. I highly recommend looking up Cascode Amplifier on Wikipedia if you're interested in understanding the circuit further. I'm going to stop talking for a bit and speed through the rest of the schematic. Okay, our schematic is looking good. Let's run the electrical rules checker to see if we made any mistakes. It found something. We don't actually have a problem here, but it's alerting us to not understanding how the circuit will be powered. We can fix this by adding power flags to our 2 signal pins. Now when we run the ERC checker again, everything looks good. Alright, well that's it for this one. Hope to see you in the next video where we lay out the PCB. Catch you next time.